In the following example, we're asked to find the area of the region bounded by the following curves: y equals x squared plus 1, y equals negative root x equals 0, and x equals 2. Placing the lines x equals 2 and x equals 0 on the graph give us this line. X equals 0 is the axis. So the region of interest here is this region in here, both above and below the x-axis. So we need to find some points of intersection. So this point is x equals 0 along the line. Notice that the curve touches at two different places here, so the y values are actually different. The x value here is x equals 2. We can evaluate all these points. Here we just plug in 2 into the equation, so this would be 2 comma 5. This would be 2 comma negative root 2, 0 comma 0, and 0 comma 1. Now we need a representative rectangle. This time we're going to draw the dy rectangle first. Let's make sure it stands out over our shaded region here. So here's our dy rectangle. Now as this rectangle moves, notice here the top remains on the curve, the bottom remains on the line x equals 2. But notice what happens when we reach this point here. The top is no longer on the curve. The top is now on the line x equals 0, while the bottom remains on the line x equals 2. Since the top and bottom of the rectangle have now changed, the area would need to be represented by a second integral. If we continue moving, we notice that now the top is a different curve again, giving us a third integral to represent the area. Typically, if we have more than one integral to represent the area, it becomes a little too difficult. So we're going to try a dx rectangle to see if we can represent it with just one integral. So if we change that to a dx, and we move that through the region, the top is on the upper curve, x squared plus 1, the bottom is on the lower curve, minus root x, and that remains the same from 0 all the way to 2. So we have one rectangle here that represents the entire region, rather than 3 that would be necessary for a dy rectangle. Given that, we choose dx, as it will be simpler. Certainly simpler to set up. Not always easier to integrate, but you have to set them up to know that. So area is equal to the integral from 0 up to 2. It's going to be dx, so all of our variables need to be x. The top curve is x squared plus 1 minus the lower curve, which is negative root x, or negative x to the half. Before we integrate this time, we're going to simplify a little just to make it look neater. So x squared plus 1 minus becomes plus x to the half dx. Now we can go ahead and integrate, getting x to the 3 over 3 plus x plus 2 over 3 x to the 3 over 2. And all that needs to be evaluated from 0 to 2. So substituting in 2 gives us 8 over 3 plus 2 plus 2 times 2 to the 3 over 2 over 3 minus putting 0 in for each x value results in a 0. So simplifying then, 8 over 3 plus 2 is 14 over 3 plus 2 to the 3 over 2 is root 8. Root 8 is 2 root 2, so that's 4 root 2 over 3, which is equal to 14 plus 4 root 2 all over 3. And that's units squared. Your calculator, of course, is not going to be able to keep the radical root 2. It's going to give you a decimal approximation, and that's perfectly acceptable. Any point after this step, you can put it on your calculator and get the decimal result.